Hello and welcome back. Today we are going to work on section 12.3. We're going to work on surface areas of pyramids and cones. Yesterday we worked on surface area of prisms and cylinders. So here's a little review of what we talked about earlier on Monday about pyramids. So a pyramid is a polyhedron where the base is a polygon and the lateral faces are triangles. So sometimes students in the past have gotten mixed up between pyramids and prisms. Remember, pyramids have triangle faces, the lateral faces, and prisms have rectangular or quadrilateral faces. And so we also talked about regular, as far as prisms, like regular polygonal prisms, and here we're talking about a regular pyramid. And a regular pyramid has a base that is a regular polygon, and the lateral faces then are congruent, okay, isosceles triangles. So that's going to make a difference as we calculate the surface area. It's going to make things a lot different. The other thing that's to note about a regular pyramid is now with these triangular faces, we have another height of this triangle right here. So if I outline one of these faces right here, that's a triangle, we have two different heights. We have the height of the actual pyramid, and we have the height of the triangular lateral face. And so we call that the slant height. And we use the letter L for slant height. All right, so that's just some notes. Maybe stop the video, write those things down, or just review it to make sure you understand that. Okay, so if we're going to find the surface area of this regular pentagonal pyramid, okay, we could use this net, okay, and we could find the surface area of one of these isosceles triangles, and we could multiply it by 1, 2, 3, 4, 5, okay? So if I'm looking at this triangle right here, the area of this triangle right inside there, the area is 1/2 the base times the height. So the base of my triangle, if I come over here, is this right here, and that's 11.62. So the area is 1/2 the base, which is 11.62, times the height of the triangle, which is 17. So here's the height of that triangle right there. So there's your base and height of that triangle. So that's easy enough. Calculate the area, and we get 98.77, if I round correctly, times 5, and that gives us 493.85 units squared, and that's for the lateral area. That's all the triangles, all 5 triangles. So now we can work on this base. Well, this base is a regular pentagon, and that regular pentagon, to find the area of that, I'm going to move outside the triangle. The area of that is 1/2 the apothem times the perimeter. Well, luckily I was given the apothem over here. Get a different color so you can see that. Here's the apothem, okay? And so I can just plug that in. So my area is 1/2 the apothem, which is 8, times the perimeter. The perimeter is 11.62 times 5. So calculating that, my base area is 232.4 units squared. So now I take these two answers and add them together. So I take the 493.85, the lateral area, plus the base area is 232.4. Notice here we only have one base, okay? So we add those together, and that gives us a grand total of 726.25 units squared. So we can do it using a net, just like we did with cylinders and prisms, okay? But luckily there is a formula that calculates it maybe a little bit more efficiently and faster. So here is your formula for finding the surface area of, come on, give me a color here. Okay, well, doesn't want to do that. But here is your surface area of regular pyramids, okay? Notice this is regular, okay? So this is when your base is a regular polygon. So we find the area of the base because there's only one, and then we find the area of that regular polygon, which, that's the regular polygon right here. This is your base. And then this right here is calculating the lateral area. And that's just calculating the area of one of those triangles and multiplying it by the number of triangles. So remember, though, that in this formula, that L right there, the L right here is the slant height. And that's this piece right here. That's your slant height. It's the height of one of those triangles. So the slant height is the height of the triangular lateral face. Okay, so those are some terminology. Make sure you understand the difference between the height of one of those lateral faces and the height of the pyramid, because you're going to be using both of those eventually. Not yet, but when we get to volume. All right, so let's see if we can work through a couple problems. I know this video is going to get kind of lengthy, so I'm maybe not going to solve every problem live, but you can go back and look at the notes that I post. So it says find the area of each lateral face of the regular pyramid. So what I'm supposed to be finding is this lateral face right here. Well, I know how to find the area of that triangle. The area equals 1/2 the base of the triangle times the height, which in this case is our slant height. All right? Well, the base of my triangle is 22. So here's the base, there's the base. So the base of the triangle is 22. Now I need the height of the triangle. So what I need is, I need this. I need this right here. Well, you can get that actually using the Pythagorean theorem, because you have this right here, perpendicular to the base. This is cutting that in half. It's directly in the center. So this piece is 11. So what you have is you have a right triangle with the height of 18, this leg as 11, and we are trying to find this L slant height. So we just use the Pythagorean theorem, 18 squared plus 11 squared equals L squared. So my slant height is approximately 21.1. So then I just plug that in, and that didn't find the area of the whole pyramid, but we were just practicing using some of our other tools to find missing pieces, because we would need that if we were finding the surface area. So let's go ahead and find the entire surface area of a regular pyramid here. And this is a triangular regular pyramid. So we have this triangle right here. And because it's regular, that triangle is 5 by 5 by 5. Okay? So when I'm finding the surface area of a pyramid, I have to find the area of the base. There's only one, plus 1/2 the perimeter of the base times the slant height. Okay, well, let's fill in the things we do know. We know the perimeter, okay, because it's 5 plus 5 plus 5 or 15. We also know the slant height. It's given as 7.5. So we have this right there. Okay, that's the slant height. We just had to find that on the last problem. So now we need to work on the area of that triangle. Well, it's regular, okay? And so if we draw in, okay, we know that because it is equilateral, that this is going to be 60, 60, 60. So that makes this a 30, 60, 90. And remember, in an isosceles triangle or equilateral, this piece right here is the angle bisector, the perpendicular bisector. So that makes this 2.5. And it's the median, the altitude. So what I know now is the height in a 30, 60, 90, we have our x, we have our 2x, and we have our x root 2. So this is 2.5 root 3. So now I can find the area of this triangle. The area of that base is 1/2 the apothem, which is 2.5 root 3, or just, we could use the triangle formula, I guess, times, there we go. So here's the base of the triangle right here. So there's the base of the triangle right there. That's the height of the triangle, 2.5 root 3. And if we add all of these together, when we find the area of the base, that gives us about 10.83. And if we find the other lateral area, the 1/2 the perimeter times the slant height piece, that's 56.25. And then we add those two. So this is our lateral area if we're asked for that separately, which they do. It's just to kind of check your work along the way. So our total surface area for this regular pyramid is 67.08 units squared. All right, so of course we're gonna get some ones with trig, okay? And so like this one right here where we're talking about a regular octagonal pyramid with a base edge length of 8 and a slant height of 12, etc. Find the surface area. Okay, I'm gonna work this one out for you. I'm not going to do it live because I know we're going to get long, but just keep in mind that if you sketch an octagon, even if it's not the greatest, it can sometimes help you kind of see what's going on. And then the part that's going to be challenging, I think, is finding, for our surface area, is going to be finding the area of the base, because it's a regular octagon with side length of 8. And so we have to use the formula 1/2 the apothem times the perimeter. The perimeter is not bad because it's 8 times 8, 64. But it's going to be that apothem that's going to be difficult to find. And we're going to have to use trig to do it. And in order to do that, remember we have 8 triangles inside here. Okay, and when we take 360 and we divide it by 8, that gives us 45. So that makes half of it right here, 22.5. So then we have a right triangle where this, when we drop down, this to find the apothem right there, okay, there's my angle, that I'm going to have to use trig. This part is 4, and we did these, we've done these several times. We did them on the chapter 11 test even, but we're looking at opposite over adjacent here, so we're going to end up having to use tangent to find A. So the tangent of 22.5 is equal to the side opposite 4 over A. And then we cross multiply to get our A value. Our apothem is going to be approximately 7.17. So I'm not going to finish this one up right now, but I walked you through again that tough piece a little bit for the apothem. So let's go on to cones. This is actually kind of a really interesting formula. I really like being able to describe where it comes from, but I know that on this video and not being in person, it's going to be almost impossible. But let's just take some pieces here. Cones, when you break them apart for a net, this is what you get. So if we're finding the surface area of a cone, we're really going to find the surface area of this base right here, which we know how to do. That's just the area of the circle. And then the other piece, when you cut this, like if you think about those old, like an ice cream cone or some other kind of cones, they used to have water fountains that had the cone-shaped cups. If you cut them up, this is what they look like. I actually have a model of this in my classroom. So the other piece that we need to find here is we need to find this area of a sector, okay? And if we just add those together, that's how we get this formula. We get pi r squared for the area of that circular base right here. So this is our base area from that last figure. And then this piece right here, this pi RL turns out to be the area of that sector. And if you look through the notes that I'll post, it actually kind of walks you through it, okay? We know to find the area of this sector right here, that piece right there, that the area of the sector compared to the area of the whole circle right there is going to be the same proportion as the degree compared to 360, okay? And also the arc length is this arc length compared to the circumference. And that arc length is really just this arc length right here comes from this. So it's just the circumference of that smaller circle. So we take the circumference of the smaller circle, which is the arc length, compared to the circumference of the larger circle. And if we fill all those things in, okay, we actually end up cross-multiplying, cross-canceling things out, and it simplifies all the way down here to pi RL. And again, I've worked it all out in the notes, but I'm not going to take the time to go back and re-explain it now. You can check your textbook too, they give a pretty good explanation there. So here's our surface area of a right cone. Pi R squared plus pi RL. That L is our slant height again. So this one, again, just like cylinders, is almost easier to do than the regular pyramids because we don't have to worry about finding apophthegms using trig and so forth. So find the surface area and lateral area of the right cone. Okay, so the surface area of the cone is the area of the base, there's just one, plus pi RL. And remember, if you didn't write that formula down, make sure you do so that you have it. And so our base is just a circle, so we get pi times our radius squared plus pi times our radius times our slant height. We don't have a slant height here. We got to get that. Okay? Well, we can get it using the Pythagorean theorem. So we have a right triangle. Here's 6, here's 4. So we can take 6 squared plus 4 squared and set it equal to our slant height squared. And when we go through and do that, that would give us a slant height of approximately L is 7.2. And what I should have put in here is the 4. So now we just multiply all that together. This again is the lateral area, and that ends up to be 90.62. We add that with the 16 pi for a grand total of approximately 140.89 units squared. You could actually get this in terms of pi as well and leave it in exact form. All right, that's basically all there is to it. Here's one more where we work backwards that I'll do. And so it says the surface area of a right cone is 453 units squared. The radius is 11. Find the slant height. So surface area equals the area of the base plus pi RL. So the area of the base is pi times my radius squared, so that's 11 squared, plus pi times my 11 times my slant height, and I'm going to set that equal to the 453. So now I get 121 pi plus 11 pi L equals 453. Now be careful here, because what a lot of students want to do is they want to add the 121 pi and the 11 pi, but you can't because that's multiplied with the L. Okay? So what you have to do here is not that, is we want to subtract 121 pi. So if I take 453 and I subtract 121 pi, that gives me approximately 72.87 equals 11 pi times L. So now is where I can divide by 11 pi. So I'm going to take my answer. I left it as a longer decimal than this. So I'm just going to take the long decimal answer, divide it by 11 pi. And that gives me, whoops, an error. So I'll just try one more time. 72.87 divided by 11 pi. And that gives me that my slant height is approximately 2.11. And it is in units. All right. So you might encounter, actually we're going to work on some of these tomorrow, some of these combination figures and some other surface area applications that are a little bit more challenging. But if you were doing this, you'd just find the pyramid surface area and the prism and add them together. No big deal. So see if you can stretch your learning to a new situation. So here's your learning targets. Again, I'm going to have you pick 15 questions. Make sure you're showing your work, checking your answers. Okay, I'll host a Zoom session tomorrow. Actually, I think I'll host either tomorrow or Thursday, so check the updates so that you can come in on my Zoom session and ask me questions on things you're not understanding. All right, well, good luck. Have a great day.